This is the second example of creating multiple representations. In this example, we were given a table. And we want to take this table and we want to come up with a situation, story, or picture, a graph, and an algebraic rule. So the easiest way to start this is to look for a pattern. What do we notice in this table? Well, it looks like on the x-axis, our independent variable, we are going up by ones. And on the outputs, we start at 10 and we go up by 2s every time. So we need to think of a situation where we would start with 10 of something and then increase by 2 each time. So we could really come up with anything. We could talk about money and time. We could talk about volume and time, money in weeks, however you want to describe this. But I'm going to talk about maybe renting something. So in our situation, let's see, what do we want to be renting? I'm going to go ahead and rent a bicycle. Yeah, that sounds really good. So I'm renting a bicycle and the cost is increasing over time. So my inputs would be time, and we're just going to use hours. And the output would be cost, and our units would be in dollars. So according to my table, we start off with $10 and then we go up $2 for every single hour that I'm renting. So that is essentially the scenario that we just created. So our situation, I'm going to go ahead and write a situation down. My scenario is Maria is renting a bicycle to ride around town. There is a flat fee of $10 and then she pays $2 every hour. So the more specific your story can be, the better. I explain very clearly how much it starts at, flat fee of $10, and then I explain how the rate changes. We're going up by $2 every hour. So that would be our mathematical pattern in words. We would start at 10, then add 2. Over and over again. So we're going to take this information and we're going to go ahead and put it into a graph. So we can just plot the points that we have on our table. Don't forget to label your axes. I'm going to go ahead and plot the points. So 0, 10, 1, 12, 2, 14, 3, 16, 4, 18. Now, although my table stops at that value, I can keep going just by following the pattern. I go up 1, over 1. So my slope is up a tick mark, over a tick mark, even though they're not really going by the same amount. So there would be our graph. So we're going to take this graph in this table and we're going to create an algebraic rule. So our independent variable, which are the inputs, that's the time. It's important that we know this. The output would be the cost. And I need to create a rule. This is where that process column comes into play. It becomes very useful, and where our pattern really comes into play. So for 0 hours, I am spending $10. For 1 hour, I'm spending $12. For 2 hours, I'm spending $14. So the only way to get from 0 to 10 is to take 0 and add 10 to it. So I know that's going to have a plus 10 in my rule. It's the only way to get from 0 to 10. So the next thing I want to look at is, well, then where did all this other information come from? Well, to go from 10 to 12, I really had to add 2 to it. To go from 10 to 14, I added 4. And to go from 10 to 16, I added 6, and so on and so on. So I'm looking at this pattern. Well, now I want to see the relationship, because every single one of these has a plus 10, but how does this time piece, how does that relate to these numbers? Well, we can see that to go from 0 to 0 and 1 to 2 and 2 to 4 and 3 to 6 and 4 to 8, I'm really multiplying my time by 2. So if you can see that this number being multiplied by 2 gives me this number, right? 0 times 2 is still 0. 1 times 2 is still 2. 2 times 2 is still 4. 3 times 2 is 6. 4 times 2 is 8. So it looks like our rule is I'm going to take my hours, multiply them by 2, and then I'm going to add 10. And that's how I end up with my cost. So that means my rule, my cost, I'm going to call that y. Y is equal to my number of hours, which is x, times 2, and then I'm going to add 10. So this rule now represents any cost for any number of hours. So although all of these representations look different, they all still represent the same scenario or situation, and they all still give me important information. I can see that here I'm starting at 10 and I'm going up by $2 every hour. Same thing here, I'm starting at 10 and going up by $2 every hour. Even our equation, a linear equation, we're starting at 10 and we're adding 2 times every hour.